Hi friends, so we're just going to talk a little bit about sequences and patterns and how to write rules to explain patterns. And we're going to look at a couple of different types of patterns, but the first type of pattern that I really want to look at are arithmetic sequences. They're sequences that go up or down by a constant rate of change, we would call it, or in this case, we're going to call it a constant difference. And that constant difference we refer to as D here, right? It's just the constant difference. But you know it from other places as the constant of variation, or K, in a direct variation equation, or you'll know it as the constant rate of change or slope of a linear equation, M. So it's the same, it's just I picked a different letter for it, okay? So what I'm really thinking about is I'm thinking for a sequence, I have, hey, this is my first number in the sequence, 1, and then the second number in the sequence is 3, and the third number is 5, and the fourth number is 7, and then 9. So I'm really thinking about, hey, what number, what position am I in the sequence? Am I in the first position, the second position, the third, fourth, or fifth? So n's just where you are in the sequence. And then this D is how I'm changing. So if I look here, I'm going up by 2, and then I go up by 2 again, and then I go up by 2 again. So the D is 2. I'm going up 2, so I can even put a positive there. Okay. So if I'm in the fourth position, I just chose that one randomly, and I want to know how did I get to this 7? Well, the most straightforward way probably to think about it is, hey, look at the number before. The number before was 5, and then I added 2. So if I'm interested in this position, this output in the fourth position, I want to look at the third position to see where it is. And so basically we're saying if I look at the output of any position, the function, the A, the value, right, at any position in my sequence, what I really want to do is I want to look, hey, let's look at the number before, right? So if I'm interested in 4, I want to look at 3. Where's 3? Well, 3's at 5. And then to that, I want to add 2, right? So this is the rule. This is the recursive rule. It just says, hey, look where you came from and add 2 to that, okay? So if I look at 4 and I look for the recursive rule. So again, I've got some positions here. I've got my first position, second position, third position, fourth position. And so here, my rule, my A sub n for the recursive rule is, if I want to know about the third place, right, A sub 3 would then be look at A sub 2. And so that's 1 less than 3. And then each step along this way, I'm just subtracting 9. So my constant difference here is -9. So that's my recursive rule. This is my recursive rule. And this I could go to any place in this position and say, hey, just look at the number before, add 2, and that will give you the number that you're curious about. Okay. Now, often we are not satisfied with recursive formulas, because what if I don't know the number before? What if I want like the 5,000th number in a series? Then I have to do this 4,999 times to get to the one before so that I can add 2 to it. And that seems like a lot of work, and I don't have time for that. So instead, I'm going to want to have also an explicit rule, a rule that works for any place right off the bat. I don't have to think about where I was at in my sequence. And so the rule for that is any output, the output at any position, is equal to the first number of your sequence. So I look back at the sequence, and the first number of my sequence here is 1. So I take 1, and then I add to it, and then I'm going to multiply the constant difference, right, because we're just doing that every time. So if I do it 5 times, it would be 5 times 2. If I was doing it 100 times, it would be 100 times 2. But remember, I'm not starting at the 0th position, right? I'm not starting at the beginning. I'm starting 1 in. So I want to know what is 2 times all of the positions minus that first position, because I already have accounted for here. Okay, so a sub n here would be equal to 1 plus 2n minus 2, or 2n minus 1. So that's my rule. Okay, so the output for any position along this function, I would just plug in. So if I wanted to know what is the 100th number in this sequence, the a of 100 would just be 2 times 100 minus 1, or 199. Okay, and that way I don't have to count all the way up to get there. Okay. If I take a look at this one, I could write an explicit formula. Again, I'm just interested in, for whatever the excuse me, position I am in the sequence, I'm going to start with my first spot. That's 81. I start with 81. And then I'm going to multiply my common difference by the number of spaces in the sequence minus that first one, because I already have where that first one is. So that's minus 9 times n minus 1. So again, distributing just gives me 81 minus 9n plus 9, or minus 9n plus 90. And that's my output. And then I could figure out the actual value for any place in the sequence by just plugging in where in the sequence I was curious about, in for n. Okay. So I chose 1 and 4 to look at there because those are both arithmetic formulas, but you can also have a recursive formula for a non-arithmetic sequence, and they are quite useful in that regard. So here, for example, if I'm interested in the 1, 2, 3, 4, 5th position here, I would, in order to get this, I would say, hey, look back at the position before it, right, the 4th position, or the 5 minus 1 position. Look at the one before. Take that number, right, which is 16, so this is 16, and do what to it? Multiply it by 2. Okay, because this one is multiplying by 2 every time. So this one has what's called a constant ratio, right, which is that we're multiplying by 2 every time. Okay. Here in this one, I'd say, hey, for anyone in the position, so maybe 3rd here, 15, well, I look at the one before, look at a minus times n minus 1. I should technically put these in parentheses. There we go. And I'm dividing it by 2. So I could do divide by 2, or I like to say multiply by a half. Here, I have 1, 1/10, 100th, 1,000th. So if I'm interested in like the 2nd position here, I would say, well, I take this and I divide it by 10, or I multiply it by 1/10. So a sub n equals a times n minus 1 times 1/10, or 0.1, and that is my recursive function. All of these are geometric because we are multiplying or dividing by a constant ratio. Okay, I hope that clarifies a little bit. We will go over this in more detail in class on Friday, but I just wanted to make sure that you had something to look back on in case you were not fully present and mindful about this in class today. All right, thanks so much. I will see you guys on Friday.